Hello and welcome to a new lesson, and you want to know something interesting? I recorded this entire lesson last night, but it was so confusing that I just decided to do it again. Yeah, I guess, I at least know what I'm talking about a little bit more now, which should make it a little bit easier on my behalf. But anyway, yeah, today we're going to be talking about a new utility, and that utility is going to be interfaces. And really, in GUIs, graphical user interfaces. So some examples of some GUIs in Minecraft. There's a GUI at the bottom here where the player can select whichever tool they want to use to mine or place blocks. In a game like RuneScape, just even the login screen has some basic GUIs. You have a GUI down here, you have a GUI over here, and this whole thing is a GUI where you can just click new user, existing user to log in. So yeah, that's pretty much what an interface is, just something that the player can interact with. So graphical user interface. So today we're going to be working on two classes. That is GUI.java, and that's going to be in all caps. And then we also have GUI button.java. Okay. These are going to be two separate classes. One is going to be a class, and one is going to be an interface. The button's going to be an interface because the button will just kind of define what the methods and the regions for a button is going to be defined as. Whereas the GUI is something you can actually create and set. So anyway, let's go ahead and first of all, there's something I do want to do. In our game object class right now, I want to add actually a new method, and whenever you add something to game object, this means that any game object we have to also implement that method, which is kind of sucks, but most of our objects so far are not going to use this method, but really this method is something we are going to need and we are going to use. So we are definitely going to need to put this into game object. It's going to be pretty hard to get around doing this. So pretty much all this method is going to be is handle mouse click. Okay? So whenever the mouse is clicked anywhere on the screen, all of the game objects will be called. This method will be called in every single game object that's in the objects area in game. And you know that each game object can decide whether it wants to even worry about that or not, but it's gonna happen anyway. So call whenever mouse is clicked on canvas. Doesn't matter if it's in the region of this game object. We have no way of really checking that. It's just when it's gonna be called. So the parameters for this are going to be the rectangle, which represents the mouse region, the mouse rectangle. And we'll also actually have some zoom parameters, just in case we need to check. The game object needs to mathematically decide whether the zoom needs to be put into the equation or not. Right now, it has no way of getting that other than from the render method, so that's why we're doing that. And the other thing we will need is, well, every game object will have to implement this method in some way, whether it's a blank method or not. So an animated sprite. And you know, something else we could do is, implements game object, which also implements clickable or something. We have another interface which just has this method, but it just seems like something that's so required, I guess. So we're just gonna do this. So we're gonna copy this constructor or this method in, and just create a blank body for it so that we don't get compiler errors. So there we go. So animated sprite was a game object. What else was a game object? Player was a game object. So we'll go ahead and put in, the blank method for that. Oh, yeah, I have to. There we go. Alright, and then what else is a game object? I think that might have been it that we have so far. So yeah, there we go. Let's just make sure that's true by running the game quick. Yep, there we go. Okay. So if we have like an interface in our game, whenever that interface is clicked, well, we won't know whether it's within the range of the interface. We'll just know that whenever anything is clicked, whenever there's a click anywhere on the screen, that interface will be called and the mouse position will be sent to that interface. So, or that GUI. I'm going to go ahead and call this GUI. The reason I'm not just going to call this interface.java, you can do that. It's just it kind of like we have interfaces in our game as well, like these game object interfaces, and I don't want to be confused. I don't want to confuse between the two. So we're going to have GUI.java and GUI button.java. So let's go ahead and open up GUI.java first. This is going to be a class, as I said. And this is just going to not extend, but implement game object. Okay? So that just means we have to go ahead and copy all of these methods into GUI and create bodies for them. We are going to use pretty much all these methods in the GUI class. So, yep, pretty simple. Oops. So, yeah, that's the game object stuff implemented anyway. And then we're going to have a constructor for a GUI. And the constructor for a GUI is going to take a few things. It's going to take a background sprite is probably what we'll want, but it doesn't have to take a background sprite. So what I like doing is if I'm ever going to have anything, any class or anything in Java that has multiple constructors, so I guess just classes, I will write the most difficult constructor and then write other constructors that don't have some of those parameters that all just call the most difficult constructor. So this will be the most difficult constructor, I guess. So we'll have a background sprite. We will have an array of buttons. So GUI buttons, and we'll have an X and a Y position for the top left of the interface. And then we're going to have a boolean in here. We're going to go ahead and call this boolean fixed. So pretty much what will happen, GUI buttons doesn't exist right now. But pretty much what will happen is some of the interfaces we might not want to be fixed. For example, let's say we're opening like a chest in some like roguelike game. And when we open the chest, we want the chest inventory to stay wherever the chest is. So that'll move whenever we move the camera around. But if we just want like a GUI that stays in the screen, kind of like the Minecraft block placing GUI, then fixed will be true. So pretty simple, and we're just going to have some class variables, so fields to store some of this stuff. So private sprite, background sprite. We need this dot background sprite equals background sprite. We need to also store the buttons. So we'll make that private. So this dot buttons equals the buttons that we're passing in, and we also have an X and Y. And actually what I'm going to do for this is I'm going to go ahead and have a private rectangle. We're just going to go ahead and call this rect. I don't like contractions too often, but for this it just seems like something that is used so often that it's okay. So I'm going to go ahead and actually instantiate that in the field. So we can just do rect.x equals x, rect.y equals y, and the rect width and height is actually going to be the width and height of the sprite. So background sprite.get width, and height will be background sprite.get height. Okay. Cool. GUI buttons still doesn't exist. So anyway, that's going to be our most complicated constructor. We're going to go ahead and create another constructor here. Delete the body for now, which will not take a background sprite, but will take an array of buttons. So pretty much if you don't have something in the background, all you have is a bunch of buttons and you want them to appear on the screen. So all that's going to do is set background sprite to null, or it's actually going to call the other constructor, which is passing null in for the background sprite, and everything else is going to be the same. So pretty simple. Now the only problem with this is we need to figure out the width and height of the sprite. So what we do is pretty much, or width and height I mean of the interface, but you don't necessarily need this actually. We won't be using that too often. So all we're going to do is if background sprite does not equal null, then we will ask for the width and height of the sprite and set that to our background, to our GUI width and height. But I don't even think we'll be using width and height. It's just kind of something that's there in case you want to get the width or get the height of an interface. So we're not going to worry about that too much. So am I getting any other errors other than GUI buttons? No. Okay, anyway, let's go ahead and just create this class so I can stop getting that error. So GUI button, and actually this is GUI button, not GUI buttons. That might also be why. But public class GUI button is going to extend, or sorry, I keep saying extends, but it's going to implement game object. It's also going to be a game object. So then we need to go ahead and copy in all these methods again. And pretty much what GUI is going to do is call all these methods within GUI button for every button that we have in our graphical user interface. So now this should compile. Oh, yeah, well, this also needs to be GUI button array. So there we go. Now we are, we get all that stuff saved. So render is going to be relatively simple for now. So if, we're just going to go ahead and render what we know. So if background sprite does not equal null. So if the background sprite exists, we do renderer dot render sprite. So let's go ahead and open up render handler. We have the render sprite method that's copying all of these parameters, and there's something else we're gonna have to do, which might be a little bit annoying. We have to do right now because this is something we need in our engine. Anyway, background. Well, I'll get on that in a second. So background sprite. The x position will be rectangle.x, y position will be rectangle.y, and the x zoom and y zoom is what is passed in. So pretty simple. And the only non-simple thing is that we have this boolean fixed, right? So let me go ahead and actually make a field for that as well. This dot fixed equals fixed. Okay, and the thing is that we have two options here. Right now, every render method within render handler, render sprite, render image, render array, everything always just renders and offsets by the camera, right? But what if we didn't want to offset by the camera? What if instead we wanted to have something fixed on the screen like we do with the graphical user interface? Well, what we could do is in the GUI class, we could just offset it by the camera, so then it was offsetted again by the camera and it just kind of like reset. I think that's a little bit kind of just like too much work for something that's relatively simple. So what we're going to do is actually pretty much go all the way down to the main method, which is setPixel, and in render handler, and had a boolean here to see if it's fixed. So pretty much what we do here is we have all of our stuff coded if this is not fixed. So we pretty much do if not fixed, and then we have all this stuff happening. Else, if it is fixed on the screen, we don't want to offset by the camera. So it's actually relatively simple. If x is greater than or equal to 0, or if y is greater than or equal to 0, we don't have to worry about like the x positions and y positions of the camera. And x is less than or equal to camera.width, and y is less than or equal to camera.height. Pretty simple, actually. And then all we need to do is get the pixel index like we did before, except it's just x plus y times view.getWidth. Okay? And that is all we need to do, and this can actually become a one-liner. And what I'm going to do is actually ask for the pixel index up here. Well, I'm going to have the variable up here. So int pixel index equals 0, and then we do pixel index equals that there, and this will end up being a one-liner. We're going to copy this down below, and there we go. So we pretty much just made it so that we can render things that are fixed on the screen. Yeah, so this needs to be just pixel index equals that. And then down here, we check to see if it's game.alpha, and if it's not, we will render it. So now what we need to do is every single time setPixel is called, we need to have that boolean. So for render array, we need to ask for a boolean fixed. Okay. I'm actually going to put that in my clipboard so that's easier for me. And that's going to be another parameter in the setPixel call. And then we have render array up here for render rectangle. That's going to be boolean fixed. It's just going to be fixed. And then up here we're going to have boolean fixed. And then same here. And then same here. And then render handler is actually done. We just went through and added that fixed parameter to everything else. Now if we go ahead and just compile everything, we'll see exactly where all these problems will come now. So Java C star.java. And what's going to happen is we're going to get a bunch of errors in places that rendered, and they have to have that additional parameter. So if we go to, looks like tiles.java, We have a render tile method, we have render sprite. We know that the tiles are going to be fixed, or not be fixed. So we just can go ahead and just add false in there, because we know that tiles in our engine will not be fixed, depending on, and they will be dependent on wherever the camera is. So let's see, this is in player.java, okay. So we have, probably in the render method somewhere, render sprite. We know the player is also not going to be fixed. So we can put false in for all of these, and it'll act just like it did before. And now we should have, yep, looks like one error in GUI, and that's actually what we're doing right now. So we're just going to go ahead and pass in that fixed parameter that we had, and then if we compile everything, it should work, and we can run our game, and it'll just be like what it was before, which is pretty cool. So, yeah, I'm glad that we figured that all out. Oops, and now we can go to GUI and get cracking on this a little bit more. So now we can decide whether we want something fixed in our engine or not, which is pretty cool. So we've rendered our background sprite if we have one. If we don't have one, we won't render it. And then what we do is, what if we just had a background sprite but no buttons? I guess that's something you could do as well. That'd be a little silly. I mean, I don't think it'd necessarily be silly. This could just be a way of getting an image in your game as well. So I guess we could just do if, just for the heck of it, if buttons does not equal null, then we'll continue doing stuff. For int I equals 0, I is less than buttons dot length I plus plus. And this is actually really simple. All we have to do is buttons I, and since button is a game object, GUI button is a game object, we're just going to call the render method in that game object, and we pass in all of this stuff. So this means that all the buttons will be rendered, and here's something interesting with the GUI buttons. The GUI buttons will end up being something that we don't put in the objects array in our game, right? So that's kind of weird, I guess. This is the first time we're doing something like that. I guess we could put every single GUI button in the objects array, but I think this just kind of, it just makes a little bit more sense. So it's really up to you, but that's the way I'm going to be doing it. And then update is going to loop through all of the buttons as well, if they exist, I guess. So buttons.length I plus plus, buttons I.update game. Okay, so same thing that we have here, since it's a game object as well. So we're passing that in, we're rendering and updating if the buttons need to be rendered or updated. So, cool. So we are almost there. There's only really one more thing we need to do in GUI, and that is to check with the mouse clicks. And one thing we could do is check to see if the, first to check to see if the, what am I trying to say? First, check to see if the mouse click is actually within the interface boundaries with the width and height of the interface and the X and Y of the interface. But there's something we also need to take into account here, and that is that the mouse click that gets passed in will be actually, before I go anywhere else, I want to go back to game and make it so that a mouse click is actually being called whenever we have a mouse click. So here we have left click. Before we do any of the math with it, so I just want the pure position of the mouse without like making it a tile position or anything. We're just going to go ahead and create a rectangle here. Call it mouse rectangle. It's going to be a new rectangle, x, y, 1, 1. So pretty much x and y positions are the same, and then the width of it is 1 and the height of it is 1. And then we're going to loop through all the game objects. So I is less than objects, I plus plus. And we just want to go objects.mouse. What was it? It was handle, mouse click. We're going to go ahead and copy this in. Handle, mouse click, we have mouse rectangle, and then we have X zoom and Y zoom, which are fields in game. And then we are good. We're calling that. And then later on we do the objects I dot handle mouse click. Dot length. Wow. Okay. And there we go. Now we're good. So that's going to loop through all the objects and handle whenever there's a mouse click. So now that I've done that, anyway, where was I going? So we need to see if the mouse is within the GUI region. And the GUI X and Y variables are going to be relative to the, well, we have to see if they're relative to the camera or not. We're using the fixed boolean. So we'll go ahead and do the easiest one first, and that's just if we are fixed. So if the interface is fixed, then we need to just kind of worry about the X and Y position without offsetting by anything. But if it's not fixed, we need, and that's actually something else we're going to need here as well. I think we're going to need another parameter for this handle mouse click. Unfortunately, we're going to need the rectangle camera. Okay, so we need to go to game object. We need to go here, rectangle camera. We need to go to game object and actually add that in. Sorry about that. So, and then we need to go to all the other game objects. I don't think we have that many, but we'll see. Rectangle camera. And then we have animated sprite. Rectangle camera. And then in game, we want to go ahead and make sure we are calling that correctly. So we just do renderer dot get camera. And that should be good. Let's try running it to make sure. Yeah, okay. So anyway, now that we've done that, so if we are fixed, we don't even worry about the camera. If we're not fixed, we do. But if this is fixed, we want to go ahead and see if the mouse rectangle intersects our rectangle, okay? Now, here's the thing as well. We don't really have a good way of figuring out if something intersects. But there's actually just something I want to add to the rectangle class, which makes this very easy. And there's a special way I did it in my notes that I was kind of proud of. So we're going to go ahead and get that up. So pretty much it's just going to be a Boolean method within rectangle. So public Boolean intersects. And the only parameter this is going to be another rectangle. And it's going to go ahead and see if this rectangle intersects with that rectangle. So pretty much collides, if you like that word better. But in any way intersects. So if x is greater than the other rectangle dot x plus the other rectangle dot width, or if the other rectangle dot x is greater than x plus width, then we know that this rectangle does not intersect. Okay? There's a cool way I'm doing this. So pretty much by default, this is going to return true. But we're going to have two things here that check, and check to see if we are out of the boundaries in either direction, x or y. And if we are, we'll return false. And if not, we'll go all the way down to line 34 here, and we'll return true. So if y is greater than the other rectangle dot y plus the other rectangle dot height, or if the other rectangle dot y is greater than y plus height, so we're pretty much checking both rectangles. You're going to return false. If not, we return true. So yeah, that's pretty much how we're going to do that. And now that we've done that, in GUI, all we need to do is mouse rectangle, if mouse rectangle dot intersects rect, then we're good to go. But here's another thing. If we don't have a background sprite, then the rectangle width and rectangle height will be just 0, okay? And this will never intersect. So what we're going to do actually, and we still, if that's the case and we still have buttons, we still want to check those buttons, okay? That just means that like we have a GUI without a background sprite, which you can do. So all we're going to do is if rect.width equals 0, or rect.height equals 0, or mouse rectangle that intersects rect, okay? So if any of those things are true, and if we do have a sprite, hopefully the width and height won't be 0 for that sprite. But if any of those things are true, we want to go on. And actually, this won't need a body, but this part will need a body, I think. Well, actually, it might not. I don't know. We'll see. Anyway, so now if this is true, if this either doesn't have a background sprite, and actually we could, well, no, I like the way we're doing it, because what if we have for some reason a background sprite that had a width or height of 0, whatever. So anyway, then we want to go ahead and call for each button we want to go ahead and call the handle mouse click. So we're just going to do for int I equals 0, I is less than buttons.length, I plus plus. I'm going to go ahead and do buttons I dot handle mouse click mouse rectangle camera x zoom y zoom, okay? And this is actually all going to be just one line. It's going to be a one-liner body. So we check to see if we're fixed. And actually, we could add this to this if statement, I think. Do a little bit, maybe, well, I like the way we're doing it. This is all right. We could do like fixed and then, you know, put parentheses around these. But I like the way we're doing it. So if we are instead, well, hold on, we might want to do this a little bit differently now that I've added those extra parameters to that internal if statement. But if we are not fixed, so if this is changing depending on where the camera is, then we need to offset by the camera and check. So relatively simple, I think. We really just need to offset the mouse rectangle by the camera, I guess. So really what we could do is just get rid of this up here, and instead we just change something if we're not fixed. So if we are not fixed, then we want to go ahead and do mouse rectangle. Here's the thing, if I was to just change the mouse rectangle x, y, and width and height here, then it would change for every other method which has it. So we want to avoid changing this. We're going to have to create a new mouse rectangle, and we can go ahead and use the same variable. Basically, mouse rectangle equals new rectangle, and then we have mouse rectangle.x, mouse rectangle.y, 1, 1. Okay, and I just use that instead of getting the width and height. And mouse rectangle.x is simply going to be mouse rectangle.x plus camera.x, and then mouse rectangle.y plus camera.y. So if we're not fixed, we want to change that. But if we are fixed, then we don't even worry about it. So that makes this actually a lot simpler. So yeah, I like that. So now that we've done that, that's most of the work for GUI done. I'm not going to say everything. I'm not entirely sure yet. But now we can go ahead and head over to GUI button here. Now GUI button, the constructor. Right now we're not constructing the buttons within GUI because we're actually asking for the buttons. But the constructor is going to take a or public GUI button. It's just going to take a sprite, I think. Yeah, I guess we'll just ask for a sprite. And wait a minute, I was going to make this an interface, wasn't I? So yeah, that's actually what we're going to do. Yeah. Public interface. GUI button implements game object, and we'll go ahead and get rid of the bodies for these because you can't have them for buttons. And I guess we won't have a constructor because for this, I guess that's all dependent on whatever you want to do. So really, isn't a GUI button just a game object? Is there something else we need here, like an activate method? Well, that's kind of like handle mouse click, isn't it? I guess, well, here's the thing. I don't really want, if we were going to extend GUI button, I don't really want, like, there's some things that like overlapping in something or like figuring out the camera boundaries and stuff that I wouldn't want to implement them in each case of this being used. So I think at most we might make this an abstract class, but let's just go on with what I was thinking here, and we'll maybe change things later. I don't know. I'm just gonna figure something out, and we'll see what happens. So anyway, the constructor for this is going to take a sprite and then also a region. So I guess we'll just ask for that region. And we'll set that up here. So we have private sprite. And we have, we'll actually make this protected. Protected sprite so that all of the subclasses have access to this. Protected rectangle region. And actually to kind of stay with what we've been doing previously, we'll make this rect instead of region. So this dot sprite equals sprite. This dot rect equals rect. Okay. So that's relatively simple. And then handle mouse click, we'll see if mouse rectangle intersects with. Now here's another thing we want to do. Do we want to? One thing I'm just wondering here is if we want to check. Oh, you know what I just realized? That's not even worry about whether it's fixed in GUI buttons. What we can do is for handle mouse click, we're passing in this mouse rectangle anyway. And if we're not fixed, the mouse rectangle's offset. So we don't even want to worry about that. But what we do want to worry about is offsetting the mouse rectangle dependent on where we are in, dependent on the top left of the interface as well. So, and the reason we're going to be doing that is because the buttons rectangle X and Y position is going to be relative to the top left of the interface, wherever that is set. So when we're passing in the handle mouse click for mouse rectangle, since we already have our own copy of mouse rectangle we're dealing with here, we're just going to do mouse rectangle.x, yeah, mouse rectangle.x plus equals rect.x, so the top left of the, this will just be the top left of the interface. And once we offset that, we pass it into GUI button, and it just thinks, okay, cool, I can just see if it overlaps and stuff now. So pretty simple, making our life a little bit easier. So we won't even worry about camera within here. We're just going to go ahead and do if mouse rectangle.intersects rect. And if that's true, we want to activate something. So all we're going to do is call an activate method, maybe. I think this is how I'm going to do this. Yeah, we'll go ahead and call an activate method. This will actually just be a public abstract class, okay? So an abstract class can have its own methods, but just some of them need to be created. So public abstract void activate is one of them. So pretty much you need to override this, kind of like you would an interface whenever you extend whenever you extend GUI button. So there's stuff like handle mouse click, which we just kind of dealt with here, and stuff like render we can deal with in here as well. So renderer.render sprite. And I guess the only thing with this is going to be that we kind of would need to know whether the sprite is fixed or not. So maybe this will be something we'll have to pass in with the constructor. So protected boolean fixed. So we have boolean fixed. Let me go ahead and do this dot fixed equals fixed. Okay. So that's actually that's okay. I'm alright with that. So render sprite. Let's go ahead and copy that stuff into here so we can fill that all out. GUI button. Render sprite will take the sprite, which is sprite, the x position, which is rect.x, the y position, which is rect.y, the x zoom, which is simple enough, the y zoom, and then fixed. And remember, with these kind of methods, you can override these, depending on whatever button you have. So it's just kind of an optional thing. There's default stuff there if you need it. And actually, update's not going to do anything by default, but we will override it just in case you don't want it. Just in case an extending class doesn't even want to use it. So we won't force them to put it in there, pretty much. So yeah, that's actually pretty cool. I like the way we're doing this. We're actually using, this is a good usage of abstract classes. So you can have some default methods, but you also have things that have to be overridden, like the activate method, and I guess stuff like that. So maybe we should have, well, no, everything else we'll deal with on a case-by-case basis. I was about to say maybe we should have a boolean which checks to see if the button is activated, but that would only be if you have buttons that are activatable and not just a one-click thing. So for example, in that RuneScape GUI, the existing user button would just be a one-click thing. It's not like you would press it and then if you press it again, something else would happen. So that'll be a case-by-case basis thing, depending on whenever the activate method is called. So I guess that's pretty cool. I like what we're doing here. So now, really, it's just all about implementation. So we're going to go ahead and actually I'm going to put this, instead of making 2 episodes or 2 lessons, last time what I did is for what was it called? What did I do last time? Animated sprites. I did a, kind of a utility episode and then an implementation one. But actually this time I'm just going to do it all in one lesson. So if you don't want to worry about whatever implementation I'm going to use, you can go ahead and exit out of this video. If you want to continue on with the series and you want to see exactly how I'm going to be using this to help us out, then continue. So yeah, those are your 2 options, I guess. So pretty much what I'm going to be using this for is a little SDK editor thing. So we're going to have an interface that just lists all of the tiles we have in our game. And for every tile we have in our game, we can click on that interface and it kind of changes our selected tile. And we can click on the screen, kind of like we already are to set tiles, and that'll change dependent on what happens. So pretty much all we need for this is in game we're going to make a few methods here. Right now what we have is, I don't think we even, okay, so what we're doing is in set tile, we're just passing in 2, which is the tile ID that we're setting. I'm going to go ahead and up here just have a private integer, a private int selected tile ID. And that will, I guess, by default be 2. And then that'll be passed in with the set tile, with the set tile method down or the left click method down here. And then all we need to do is have a public void change tile or something. And what this will do is call the set tile method, or sorry, it will set tile. Sorry, oh my gosh, I can't even right now. This will take a tile ID, and it'll change selected tile ID to that tile ID. Okay, so pretty simple. Public void change tile, and then what we're gonna do is we're gonna go ahead and create a K-spaces for GUI button, and this is going to be SDK button. Okay, SDK button.java. We're going to open this up. This is going to be a public class SDK button, and it's going to extend GUI button. So yes, there we go. SDK button is not abstract and it does not override abstract method activate in GUI button. So this method needs to be overridden, okay? And we can't make this abstract this time because this is not an abstract class. This is something we can instantiate. So cool. We have a public void activate. Then, as you can see, constructor GUI button and class GUI button cannot be applied to the given types. Pretty much, there's no default constructor for GUI button. Let's see. Could we have one? You could have no sprite, no rectangle. I'm going to go ahead and say that we do need a constructor for this. So we're going to go ahead and create a constructor up here. And this is going to go ahead and since it's a case-by-case basis, I know exactly what it's going to be used for. This is going to be SDK buttons. We're going to go ahead and take a sprite, tile sprite, and then that's actually probably it, right? No, we also need to know where this is going to be. So we need rectangle rect, and whether it's fixed. I'm going to go ahead and say that we know it's going to be fixed. So we're going to go ahead and do super. Super calls the super constructor in GUI button, which we need to do. So tile sprite rect, and then true. We know this is going to be fixed. Okay, so pretty simple. We got all that figured out, and what I'm going to do actually is after the super is called, I'm going to go ahead and create a rectangle rect up here, which stores that rectangle, which I think we actually, no, we're doing that already. My bad. I'm sorry. So the super constructor will automatically store that in variable rect, in field rect, which we have access to since it's a protected rectangle. So that actually is very cool. So what I'm going to do to test this is, actually I am going to override the render method. And the reason I'm going to do that is because I also want to render something else. So we copy in this render method. This will automatically override it. We can go ahead and put this in, and Java would tell us if it really is overriding. Oh, this needs to be a capital O. And it says if this was a method like render a D or something that didn't exist, it would say method does not override or implement a method from super type. So the override call wouldn't work. So sometimes I just use that so we know what's going on. And I'll keep that there so I just know that that's being overridden when I look at this in the future. It's completely optional. But I like doing it so I know. And if you just had like some random method which wasn't overridden, it would tell you, which is actually pretty cool. So pretty much we're going to have render sprite stay the same. But then we're also going to have render rectangle, okay? Because I actually want to have a rectangle in the background, so we don't just have the tile sprite in front. I think that'd be a little bit weird. So what we do up here, or not up here, all we're going to do is actually generate graphics for this rectangle. So we're just going to do rect.generate graphics. And I'm just going to go ahead and open up paint.net and get myself just kind of like a yellowish color or something, which is going to be like the background for our SDK tiles. So if I go ahead and just figure out what I want this yellowish color to be, I guess we'll go something like that. I'll copy that in. I'll pass that in. Okay, sorry. Yeah. So that's good. We're generating graphics for that rectangle. And then we just want to do renderer. Well, before I render the sprite, we actually want to render the rectangle. So renderer.render rectangle. And we'll pass in we'll go ahead and find whatever the parameters are for that, which we have here. So in SDK button, we'll go ahead and put those parameters in. So the rectangle is just going to be rect. The X zoom will be X zoom. The Y zoom will be Y zoom. And then fixed will be true. Well, we can go ahead and pass in the fixed variable since we have access to that anyway. So yeah, there we go. Now, what's going to happen is we're going to have a rectangle, which is going to be the exact size of the tile, and then we're going to render the sprite over that, which is the tile sprite. But what I actually want to do, well, actually, let's go ahead and see if this works first the way we have it. So let's actually create this GUI. So in game, what we're gonna do is right before this object sim, we're gonna load STK GUI. Okay, and what it's gonna do is gonna create a new interface. Well, it's actually gonna create buttons first. So first of all, we need the GUI buttons array. So GUI button buttons equals new GUI button array, and it's gonna be size however many tiles we have in this game. So what we can actually do is, I think in tiles, we can create a few methods to make this easy for us. We can go ahead and say we have a method called public int tile size, or yeah. So I guess we just have a size method, to be honest with you. So it's like tiles.size, and this will return tile list dot size. Okay, and something else we're gonna also need is also public sprite get sprites. So pretty much this will get the sprites for every tile in the game that we have. So this will create a sprite array, sprites, which equals a new sprite array. And we'll actually we'll use the size thing we had before. Cool. And then for int I equals 0, I is less than size I plus plus. We are going to loop through the tile list. We're going to do sprites I equals, we'll actually do sprites.length to make this make a little bit more sense. But we're going to do sprites I equals tile list dot get I dot sprite. And then at the end of this, we're going to go ahead and return sprites. So that's pretty cool. I'm making this a little bit fast. Sorry, guys. I'm just kind of implementing this with like a little SDK editor. But in tiles, we just made a get sprites method so we can get all of the sprites easily in game and create our SDK. So GUI buttons is going to be a new GUI button tiles.size. Okay, that's how many buttons we're going to have, because we're going to have a button for every tile in our game. And what we need for the buttons is to define the rectangles as well. So the GUI buttons or the SDK buttons constructor is going to take a tile sprite and a rectangle. So what we're going to do is for int I equals 0, I is less than buttons dot length I plus plus. Buttons I equals new SDK button. Because remember, that's just the subclass of GUI buttons. And the tile sprite is going to be buttons, what we're going to do here as well is we're going to have sprite array tile sprites equals tiles.getSprites. I think maybe the tile, never mind. And this is going to be tile sprites I. And then the rectangle is going to be a new rectangle equals new rectangle. The x position is going to be, I guess, 0. And the y position is going to be I times 16 times x zoom. So, yeah. Because I'm just going to have like the tiles go down in a list. And then the width is going to be 16 times x zoom. And well, actually, for this rectangle, it's going to be zoomed later, so I can go ahead and just make the width and height like 16 and 16. And then we pass that into this constructor. And there we go. So we're creating all of the buttons, and now we need to go ahead and just create the interface. So we're going to go ahead and do GUI equals new GUI. We're going to pass in all the parameters we need for our GUI. And we're not going to have a background actually right now. We're just going to go ahead and use this other constructor. This is one of the reasons I created it, because I kind of knew this would happen. So we have buttons, and then we have the x position of the interface, which I'm just going to make like, I don't know, 10. Y we'll go ahead and make like, well, actually we'll make it like 5 and 5, and then fixed will be true. So that's cool. We pass that in, and then we just want to do game object, change that to size 2. And set objects1 to GUI. So now if we run this, we have all the tiles on the side of our screen The only problem is that they are, first of all, not offset by our x and y positions. Let's go ahead and see why that was happening. So it's because we are calling the render method, and the render method is just rendering the sprite without even thinking about the position of the interface. So actually, I just need to think here about exactly what we want to do. Maybe what we do is, in GUI button, we make a different render method that just calls the other one once it's done. X zoom, int, y zoom, but also takes the x position and y position. Oh, I guess the rectangle interface region or something, interface rect or something, I don't know. That's what we'll do, and then we'll do render.render sprite rect.x plus interface rect.x rect.y plus interface rect.y x zoom and y zoom. So we're offsetting by the top left of the interface. And now the only problem is here. Well, actually, I'm trying to figure this out, the best way to do this, because I don't really necessarily want to completely just remove the usage of this method, but at the same time I kind of do. I think we're just gonna go ahead and make this a blank method, and then a GUI is gonna call the other method. So render, and it also passes in itself rectangle, its own rectangle, and something's going wrong here. Method render sprite in class render handler. Okay, so this is a GUI button. Sprite x y. Must be forgetting something here. Oh, fixed. Fixed is just fixed. Okay, so now I'm gonna go ahead and actually override this method instead in the SDK button thing. And what we're gonna do is pass in, well, it's gonna be, let's see. This will be the same. And then render rectangle will be, we'll have to offset the rectangle, I guess. So this will be interesting. Rectangle rect, or offsetted rectangle. I guess we'll just set, we'll create a just a variable within here which will reference the other one. So rectangle rect equals new rectangle, and we'll just take rect.x plus interface rect.x rect.y plus interface rect.y, and then rect.width rect.height, and we'll pass, that'll be passed in. Variable rect my, okay, fine. So we'll just do this. We'll call this offset rectangle. We'll pass that into the method here, and then we are good. And we're just going to go ahead and get rid of this and put the @override call here to make sure this really is being overridden. And looks like it is, so that's cool. So yeah, so now the render rectangle, well, the render method is updated with the positioning of the top left of the GUI. And since we are offsetting it from the top left of the screen, that should be present here. Looks like it is. So now here's the other thing. That looks a little bit confusing for us. Remember how we have all those rectangles that apparently are without graphics. I actually closed out of that. Let me go back to SDK button, wherever the heck that is. There it is. Okay. I just realized another problem. We're not copying over the pixels from the other rectangle when we're creating this offset rectangle. What I actually think I'm going to do is, instead of doing all of this, I do want to render the same rectangle. I just want to also like pass in some offset positions. So if I go back to render handler, why don't we just make another render rectangle method to make this a little bit simpler. And what we'll do is this render rectangle method will take a rectangle offset. And this will just be like an X and Y position. So what we do is rectangle.x plus offset.x, rectangle.y plus offset.y. And that's easy enough. So now what we do here is we just do rect, and then we have our offset, which is our interface rectangle. So that should work now. And now here's the other thing: we don't actually see any of those rectangles because the tiles are completely layered over them. So what we're actually going to do is decrease the size of these tiles. So in render sprite, all we do is x zoom -1 and y zoom -1 in the SDK button class. And what that will do is now it's like in the top left of each one of these things. Now what I want to do is I want to put these in the middle of the things. So what we're going to do is we need to change the x and y positions dependent on the zoom. So we just do, I did the math from this in the previous lesson, which was really confusing. So I'm just going to go ahead and figure out what that math was. Give me just a second. Okay. So first of all, let me just go ahead and space out all of these parameters so it makes it easier for us to look at. So we have rect.x plus interface rect.x, but I also want this to be, I want to do x zoom minus the zoom that we're making this, which is x zoom -1, times the width of this, so rect.width divided by 2, okay? This will just center, this button, or this sprite in the center of the rectangle. So if you make this y zoom -1 and then rect.height divided by 2. So yeah, a little bit confusing, I guess. What we're doing is we're subtracting the original x zoom by the new zoom of this specific sprite, which is x zoom -1, and we're multiplying that by the width of the sprite divided by 2. So we just put this in the middle. So if I run this, each one of those sprites are now centered within the rectangles, which is pretty cool. I like that. And now what I want to do is I think I actually want to put like a space, at least 1 pixel space in between each of these rectangles, which is easy enough to do. If I go to game, what I can do is +1, probably just here. Although we'll do, what I don't want to do is if I is 0, I don't want to just like increase by 1 right off the bat. So what we'll probably do is just if I does not equal 0, tile rectangle dot x plus equals 1, or y plus equals 1. Okay, so now that's being offset, and we can see that happening. Oh, wait a minute. What's really happening? Oh wait, no. There's a better way of doing this. We just do +1 here. There you go. There you go. That's good. So now each one of these tiles is offset a little bit. We can go ahead and make that a little bit more. So we can definitely see the difference there. So this is kind of our tile selector. Now what we want to do is, first of all, as you can see, whenever I click the interface, I just want to actually first of all see if all these buttons are actually being clicked. So in the activate method, we're just going to do system.out.println clicked. So I want to see if these buttons are actually eventually getting clicked. So if we test it out, oh, doesn't look like it actually. Whoa. So it's a little weird. Okay, let me think about this for a second. Let me just see exactly what our problem could be here, and I'll be back. No, I'm gonna go through what I'm doing here. So my thing is here that I bet the mouse rectangle positions are a little different from the rectangle that represents this button. So what I'm actually gonna do is in rectangle, I'm gonna go ahead and make a toString method because we need this for debugging purposes anyway. And toString is something that each class has in Java. Every class has it, but most of the time it's just the memory address because that's what the object, like very, very super class definition of it is. But toString for rectangle is just going to be, it's going to return left bracket and then x, comma, plus y, plus comma, plus width, plus comma, plus height, plus, that's it. So that's what toString will be. And now what if I go to something like GUI button here, the handle mouse click, what we're going to do is system.out.println, and I can do mouse and then pass in the mouse rectangle, and it'll automatically toString that. And I can do system.out.println button, and then pass in this rectangle, and then we should be good. So let's see if this is working now. So mouse is 52x, 53y. So I think what's happening here is let me just go ahead back to the offset code here. So what we're doing is offsetting, when we're checking the mouse clicks, we're offsetting the mouse rectangle by the top left of the interface, which is good, I guess, but I think I should want to subtract this, not plus. I think that might be our problem. Maybe it's not. I don't really, I'm gonna pause and figure this out. I forgot as well about zoom. So actually this does need to be plus equals and plus equals. I'm not really sure why I did that, but we also do mouse rectangle dot width divided by equals x zoom, and mouse rectangle dot height divided by equals y zoom. Okay? Now let's see if that fixes our problems. I'm thinking that will. So if we go ahead and compile this, that should be a mouse clicked, and we can probably, no? Really? Okay, so we divided it by zoom, so we didn't have to worry about that later. Now if I just look at the very first one here. Hold on, I guess I'll try to figure it out a little bit more then. And I knew what the problem was. I fixed it correctly. I just used width and height instead of x and y. So first of all, we're not even going to increment this by rect x and rect y because the mouse button doesn't even care. It knows its position on the screen. It doesn't need to know where the x and y at the top left of the interface is. So we're just dividing the x and y by x zoom and y zoom, and then it's good. So if I go ahead and get rid of all these print lines now that I'm done debugging, and I go to game and I run this, this click should not register, but this one, oh, come on, really? Why is this one working then? That's not working, but this one is. 100% of the time. Wait, is it 100% of the time? You know what? What I'm going to do is I'm going to probably this time pause it and not stop. And not just like, until I've tested it, I won't come back. That's probably the best bet at this point. I wonder if it's just the fact that I'm not even asking to see if those have a mouse click. Let's see, mouse rectangle. Let me just go to GUI. Let me just go ahead and do system.out.println rectangle so I can kind of understand what's happening here. Oh, wait a minute. No, we do need to know. Well, no, we don't. Because none of these are offset actually by the top left of the thing. I don't know. I'm gonna pause and I'll come back once I know the full answer, not to waste your time, any more of your time. I still haven't solved the problem, but I'm actually gonna do something here that I'm changing a bunch of stuff, so I thought I'd record this. What we're actually gonna do is we're gonna make the rectangles perfect size dependent, and it's not going to be dependent on zoom. So pretty much what render is going to do here is instead of taking X zoom and Y zoom for the rectangles, it's going to take 1 and 1. And the zoom of the rectangles is just going to, by default, the size of the rectangle is going to be bigger. So in game, for example, this would be 16 times X zoom and 16 times Y zoom will be the size of the rectangles. And they will just render dependent on their size. And there you go, there it is. And what is happening? How did that change anything else? Let's see. Oh, I know how that changed other stuff. Okay. Rect.width divided by X zoom divided by Y zoom. That should help that. Yep, there we go. Okay, so yeah, now we need to go back and do some more. I'm going to go back and still try to figure out what's going on. That just helps us out a little bit. It makes it so that the rectangles are exactly the area we want them to be on the screen, and then the mouse can just try to figure out if it's clicked or not. I figured it out, and it was the most stupid problem I've ever had, ever. No, I mean, I've had stupider, but pretty much what I was doing is I had the mouse rect.x plus equals rect x and rect y. I had that inside this for loop, so every single time we went through a button, we'd increase it again, which was really stupid. We want to increase it once and then check every single button, so that actually solved the problem. Now every one of these accesses changes that clicked thing, so yep. So now what we're going to do is we're going to go back to we're going to go to a game object. And handle mouse click is actually going to be a boolean, and it's going to be return true if you don't want to continue. So if pretty much what it's going to do is if this returns true, we don't want to try to handle any more mouse clicks. So return true if we stopped at clicking something. Return true to stop checking clicks. We'll say that. To stop checking other clicks. Okay? So now we have to go into animate sprite and stuff like that and just go ahead and tell it to return false because we haven't clicked anything, and do the same for, wait, what? Oh. Also needs to be a type boolean. Then we need to go to player as well and do the same thing. Make this a boolean. And return false. And then we go back to GUI, make this a boolean, and we'll make it return handle mouse click of the button, and then we'll make this a boolean that will return true if this happens, or else return false if none of that happens. So pretty simple. Okay, cool. So activate if that happens. So pretty much now in game, what we do is down where we're checking clicks, boolean. We'll have a boolean here called continue, or clicked equals false. Boolean clicked equals false, and clicked will just be equal to that call. And if clicked, if we've not stopped at something, so I guess we call this stopped click or something. I don't really know. This is a weird variable. It's one of those weird ones I'm having trouble creating a name for. Missing return statement GUI.java. Yeah, so return false by default here as well. So that's pretty much what we're going to do. So pretty much if I click normally, stuff happens and I can press tiles. If I... Oh, wait. Still calling activate. We should be printing out clicked. Huh. What's going on here? It's a little weird. I think what might be happening. Well, let's try this and see if stuff happens if I do this. What the heck? This was just working a minute ago. I swear to you. What? What's happening? Oh. Duh, it's only checking the first one. Okay, yeah, that's what we're gonna do. We're just gonna have boolean click or stop clicking equals, or stop checking, I guess. This is a really weird variable. Stop checking equals false. We do stop checking equals that, and then we return stop checking. That'll work. We were returning for the first button that was clicked, which was the problem. So now we're doing that. So now what we do in game is we let stopped click, or you know what was the one I had? Stop clicking. We'll make that the variable name, or stop checking. Yeah, that's what we'll do. That makes the most sense, I think, out of everything we've had so far. So stop checking equals that, and if stopped checking, we'll do that. And the reason why we have this really is so that down here we don't bother about setting a tile if we clicked something. So we only want to do this if we have not clicked something, pretty much. So that's what we'll do. So now if I click anywhere, I can set tiles, but if I click on the interface, I'll click the interface and half the time it'll work and half the time it won't. That's my plan. No. What? Oh, you know why? Because we checked other ones. Yeah, hold on. We need to go back. We need to go to GUI here. I'm making a bunch of rookie mistakes. So pretty much what we're going to do is add a body to this for loop. And boolean result equals, and if stop checking equals false, and, or sorry, if if stop checking equals false, then we do stop checking equals result. And if result is true, then it won't override it. So pretty much if we clicked something, like what was happening is we were clicking this, but then it went on to the next button and that returned false, so it overrid the variable. So yeah, I think what I did right there is I clicked perfectly in between. Yep. If you click perfectly in between, where there's that 1 pixel space, it'll work. Wait, what? Are you kidding me? This is so weird. I think I know what's happening though, because I can click like up there, and it'll set a tile. So I think it's just not. It's still not offsetting perfectly, by the. It's not offsetting by the top left of the interface. I think is what is happening still. So I'll try to figure that out, and hopefully this will be the last time I pause. Okay, I figured out what it was once again. So in GUI, we do want to subtract by rect x and rect y the mouse rectangle.x, mouse rectangle.y. We do want to do that because if we're adding it, it's just offsetting it more than it needs to be. It's just like, yeah, just do this. Sorry for like double crossing myself multiple times. It was because I was so confused why that wasn't working originally, and that's because it was within the for loop. That was the only reason why. And I just was too blind to see that. So sorry about that, guys. But still, this recording is less confusing than the previous one. So yeah, the previous one was pretty bad. Now this, I also did something else because we were only creating another copy of mouse rectangle if the interface was not fixed. We also want to create a new copy even if the interface is fixed, because we're changing stuff and I don't want that to affect anything else that is clicked. Right now that wasn't affecting anything, but that would have affected more stuff in the future, and it would have been a pain. So yeah, now I've actually did try. I tested out a few things. First of all, I can't click around the corners. It's really hard to click perfectly in between. I don't even think it's possible because there's like a 1 pixel margin, and I don't even think it's possible to do that, which isn't a big deal. I don't think I'd be doing that anyway. But yeah, you can click on the sides and stuff, and it's pixel perfect most of the time. Yeah, I don't think it's possible to click in between. But yeah, that's pretty cool. We got our interface set up now. So now we want to have stuff happen if we click a certain button, right? So I think what we need to do is an SDK button. All we need to do is, first of all, we need to go ahead and get a copy of the game because we need that to call the set change tile method. So private game up here, we'll do this.game equals game. We also need to know the tile ID of this sprite, so tile ID. We're going to do private int tile ID. And we'll do this dot tile ID equals tile ID. Okay? So that's cool. And then in activate here, we can do game dot what was it? Change tile to tile ID. Yep. Okay. So now what we need to do here is this won't compile. This won't compile because we need to change this constructor 98. We need to pass in this, and we also need the tile ID of this tile, which will be I think. Yeah, it'll be I. Okay. So let's go ahead and test this out. If I press that, I'm now laying down a grass tile. If I click that, it's a dirt tile. That should be the grassy path tile. That should be like a corner tile. So we can make like paths and stuff now. Pretty cool. Alright, I can save map still. So if I now run that, that'll work. I just did Control S. So there's also, I also want something graphically to happen over here. So what we're going to do is pretty much whenever I click this, I want it to change green. But I'm going to do this a little bit differently because I'd have to also set all the other ones back to its original color. So what we're going to do is actually in STK button or GUI button, we have this update method, but we're actually going to override this in the STK button. Just so we have this. So at override. So we're overriding this now. Just to be sure. And what this is going to do is check to see if this is the selected tile. So I also need when I have a change tile method, wherever that is. Where is that method? Change tile. There it is. We're also going to have a public int get selected tile, which will just return selected tile ID. Okay. So now let's go back to STK button, and we just want to do if tile ID does not equal game.get selected tile ID. Well, actually, first of all, we'll do this. So if tile ID does equal game.get selected tile ID, and we'll have a boolean up here saying is selected. So pretty much like is green, and we'll set this to false because it's going to be yellow. So if cannot find symbol game.get selected tile ID. Oh. Okay, just get selected tile. So if tile ID equals game selected tile ID and we're not green, then we want to go ahead and do rect.generate graphics. I don't want to generate graphics if we don't need to. So if we are already green, which we'll just set is green equal to true if this is the case, I'm going to go ahead and find a green color in paint.net. So let's open this up, select green, make it a little bit less excruciating to the eyes. Whatever, we'll copy that in. So 0x 66ff 3D or whatever. And then sorry, and then if tile ID is not equal to that, hold on, we'll do this. We'll do if tile ID does not equal game.get selected tile, or no, we'll do an else, because what I'm going to do is we're not going to generate if we don't need to. So if is green, then we'll do this stuff, otherwise we won't. Okay, and we'll get rid of, well no, we'll still have that body, I think. Yeah, so then we'll have else here. Pretty much if tile ID is not equal to game selected tile ID, and if is green, only if we are currently green we want to go back to yellow, because we're not selected anymore. So we want to do rect.generate graphics, and that's the color up here. So we're going back to the color yellow, and then is green is going to be equal to false. Okay. So let's see if this works now. Alright, so that's the selected tile because that's the one we default start out with. So if I can select these tiles and they will change color, which is pretty cool. And yeah, I'm liking this. I'm liking this a lot. That's pretty cool. Yeah, okay. So yeah, cool. We now have an SDK editor type thing. So this interface could also be a little bit more advanced. Like for example, let's say we had like tile categories. If we clicked one of these tiles, all the different types of dirt would come up or something. We could also do stuff like that. That's very possible. It makes it a little bit more complicated, but it's something we could possibly do. But that's where I'm going to end this lesson, guys. I think we're doing pretty well. I like kind of what we got going on here. And then what's cool is if we add another tile. In fact, let's just do that to end off this episode. Let's say I wanted to add another random tile I have here, like this water tile, right? So I go to, tiles.txt, and then we just have like water. And this water tile is 0, 1, 2, 3, 4. So it'd be 4 is the sprite X. 0, 1, 2, 3, 4. 1, 2, 3 is the sprite Y. So we have that, and then we have water 2. Or water 2, yeah. And that's going to be 4, 4. And if we save that and then run, both of those tiles pop up here, and we can place them around our map. There we go. Pretty awesome. But it's kind of cool how like I like the look of this as well. You know, because we have the sprite background. We have like the background is yellow or green, depending on if it's selected or not. And yeah, I kind of like the way we're doing this. So the only other thing we can do here, if you wanted to, you could also have something to check whichever layer you're on, and if you press it, it'll change layer or something. You know, you can work on your own things. In fact, I encourage you to do so. But yeah, that's it for this utility, guys. I'm really trying to get all this stuff out of the way so that we can finally start making our own stuff now. So if I go ahead and save this now, that'll all save into map.txt. All of those tiles we just added. And then if I run, they'll pop back up again, which is pretty cool. So anyway, guys, that is it for this lesson. Thank you for watching, and I will see you next time.